Okay, this topic looks at log properties. So remember that logs are exponents. So the first rule I'm going to look at is if I added my exponents, this occurs when you multiplied variables. So that's why log base b of x plus log base b of y equals log base b of xy. You need to be able to go both directions. So if I see log of a product, I could break it into two logs being added together. If I subtracted my exponents, that means it came from a division problem. And the other one, which we use to solve equations, if I have variables raised to a power, I multiply my exponents. So we're going to break these up using log rules. So I've got m times n to the fifth. So I'm going to break this up. This becomes log base 3 of m plus log base 3 of n to the fifth. I multiplied quantities. I am adding the exponents. Then I'm going to take this power of 5 and move it out to the front. Okay, that one's sometimes, if you get decent with these, it's easy to go from here to here. Okay, let's look at one with a quotient. So I've got p squared times q over t to the sixth. Now I'm going to take an extra step because we have a division. So I'm just going to deal with the division first. When I divide quantities, I subtract their exponents. Now I've got a product here. When I multiply quantities, I add their exponents. Then I can take my exponents and move them out to the front. Again, a lot of you can kind of recognize these things and do this a little bit quicker. Okay, this one though is a bit more complicated. The cube root affects all the stuff in the inside. So when you have something that's affecting everything, we got to worry about parentheses. So I've got xy squared to the z raised to the 1/3. So I got 1/3 log base b of x over y squared z. Now I am going to be subtracting my exponents because of division, but I've got to be extra careful with this part. Now I'm going to get log base b of y squared plus log base b of z because of the product, but the minus has to be just worried about distributing it through. So I put parentheses around this, and then I could take this 2, and it can move out in front of this, and this is a correct answer. Or we can distribute the negative through. That would be a correct answer. Or even distributing the 1/3 all the way through. Okay, the other way you may have to use this is to use the rules to put pieces back together again. This is particularly true when you're trying to solve equations, because you got to get a single log to be able to solve the equation. So I'm going to take care of my rules of exponents first. 3, well, he's going to move back up to the top. The 1/2, he's going to be moving back up to the top. The 2 is going to be moving back up here. Now with the addition, I got multiplication. Subtraction, I've got division. 1/2 is the same as like having a square root. So first of all, I brought these guys back together. And now I'm going to have log base 5 of b cubed square root of a over c squared. We just got to go and put them back together again. Now, it's critical that these bases are all the same. They have to be the same base. You cannot do that unless the bases are the same. Okay, this one looks pretty nasty. So again, I'm going to take this 3, move him up to the front. And because I've got a product, I've got g plus h cubed. When I add my exponents, that makes it a product. K plus log base 3 of k plus log base 3 of m becomes log base 3 of km. Now, this square is going to go and affect all of the gx cubed. So the whole thing is going to be now squared over, because the minus, raised to 1/5 is the 5th root. And then, because the minus, I'm making a division problem. Okay, that's breaking up using log rules.